Hello, everyone. In this video, we will introduce RPIC, a simplified enterprise architect framework. Introducing methodologies often risks descending into abstract procedural jargon. To avoid this pitfall, we ground our explanation in a relatable business scenario. Let's begin with the background of our case study. The subject of this case is Pudu Catering, a growing company specializing in corporate catering services. The company provides daily employee meal delivery and event catering to businesses in its vicinity. As a growing startup, Pudu has historically relied on simple tools like Excel to manage its business data and sales orders. However, as the company scales, it now seeks to implement a comprehensive information system. The organization's need for such an information system typically arises during critical inflection points, such as expansion plans, preparations for an IPO, or other milestones that demand digital transformation. For Pudu Catering, the goal is clear: to establish a system that integrates customer management, orders processing, purchase, and financial operations. Ultimately, this system will enable its leadership to access real-time insights into customer demographics, operational performance, costs, and profitability. Pudu's organizational setup is straightforward. The sales department handles customer acquisition and payment reconciliation. A single production center manages food preparation and local delivery within a 5-kilometer radius. Logistics is outsourced but requires integration with the core system. Purchase, managed by the production center, focuses on sourcing fresh ingredients and packaging materials, which account for the majority of operational costs. Based on the background provided, this project focuses on designing the information architecture for Pudu's core business system, spanning order intake, meal production, delivery, and payment reconciliation, and implementing the entire application on a no-code platform. Administrative, human resource, and marketing functions are excluded to simplify the case. The specific deliverables include 1. Data structure definition, the foundational layer outlining business-critical data objects, like customers, sales orders. 2. Workflow blueprint, particularly those processes involving interdepartmental collaboration. 3. Functional application, a no-code built ready-to-use application system. 4. User documentation, detailed guides to ensure smooth adoption and compliance. The first two deliverables, data structure and workflow blueprint, are intermediate outputs representing the planning phase. Data objects form the backbone of the information architecture, while workflows define how teams collaborate across functions. Beyond these, the most critical deliverable is the functional application itself. In the context of HAP, this refers to the application system built on the HAP platform. To ensure its effective use, comprehensive user documentation is also essential. Together, these four outputs constitute the full scope of our project. In enterprise information architecture development, architectural design is indispensable, particularly for complex systems, where it accounts for a significant portion of the project timeline. Moreover, enterprise information architect is not a one-time effort but a continuous process. It serves not only immediate system development needs, but also long-term strategic goals, including iterative upgrades, migrations, and scalability. Since the 1970s, enterprise architect has evolved into a specialized field, offering frameworks to manage the complexity of enterprise information systems. While many methodologies originated in defense, aerospace, or government sectors, they have been refined for corporate use. Two prominent examples, the Zachman's framework and TOGAF, illustrate this evolution. The left one is Zachman's framework, introduced by John Zachman in 1987. It organizes information system architecture into a matrix of 5 stakeholder perspectives and 6 interrogative dimensions. This structure ensures comprehensive alignment across organizational layers and roles. While the framework's granularity minimizes critical oversights, its 30-cell matrix can create excessive complexity for businesses. Few organizations adopt it wholesale. Instead, many treat it as a checklist to validate roles, responsibilities, and design considerations during planning. Managed by the Open Group Architecture Framework is the most widely recognized enterprise architecture framework. It divides enterprise architecture into 4 domains: business architecture, data architecture, application architecture, technology architecture. TOGAF is currently the most renowned framework in the enterprise architecture domain, with a well-established training and certification system. Despite its rigor, TOGAF's complexity often renders it impractical for direct implementation. Like the Zachman framework, it has become a specialized profession rather than a hands-on toolkit for most organizations. To bridge the gap between theoretical frameworks and practical no-code projects, a streamlined approach is on the wish list. Next, we will introduce a simplified enterprise architect methodology, RPIC, that aligns closely with the application design process on the HAP platform. RPIC stands for Role, Process, Information, and Content. It is a step-by-step analytical and planning process that begins by breaking down the roles involved in the management and operations. Map the processes and data objects for each role, which may include external roles, interacts with, and synthesize these insights into actionable blueprints for data architecture, role permissions, reporting, and workflow design. By systematically aggregating and deduplicating these elements, organizations gain clarity on these four foundational pillars: data, role, process, and report, corresponding to the key elements of HAP application development, including worksheets, views, roles, custom buttons, workflows, charts, and custom pages. This alignment ensures a seamless transition from architectural planning to practical implementation on the HAP platform. Therefore, the RPIC framework is fundamentally centered around the needs of application development. It starts with the project objectives and examines what services need to be provided for different roles. For each role, it identifies the processes and information touchpoints required to complete their tasks. This, in turn, informs the necessary data, roles, processes, and reports, ultimately leading to the actual application build. Now, let's explore how this methodology can be applied to address Pudu Catering's requirements. The project aims to develop an ERP system to manage core business processes effectively. Specifically, it will support two primary business lines: employee meals and event catering, addressing the diverse needs of corporate clients. Additionally, the system will enable operational workflows, from sales order initiation to delivery completion, ensuring a seamless process. Moreover, it is designed to enhance operational efficiency. Finally, the system will accurately track costs and revenues, providing clear financial insights for better decision-making. To clarify an organization's information architecture needs, we typically start by mapping its value creation process, a macro-level flowchart that visualizes how value flows across stakeholders. Nodes represent participating entities, internal departments or external partners, and arrows illustrate value movement from left to right, minimizing complexity while ensuring all critical roles are captured. Roles, the foundation of the RPIC method, must be comprehensively identified to avoid gaps in process coverage. In this case, the customer places an order with Pudu's sales department. The sales department then issues a work order to the internal production center, which in turn generates a purchase order for the supplier based on the work order. This sequence represents the information flow of the entire business activity. Subsequently, the supplier delivers raw materials to the production center, where they are transformed into finished products and delivered to the customer through a logistics service provider. In this flowchart, information flow is represented by dashed lines, while physical flow is represented by solid lines. While physical flows are operational necessities, the architecture prioritizes information flows and their associated roles. From the flowchart, we have identified the following participating roles: sales department, production center, customers, supplier, and logistics service provider. Internal roles, such as sales, chef assistant, are defined by specific functions, while external roles, such as suppliers, logistics service provider, are treated as singular entities interfacing with designated internal teams. With this analysis in place, we will now systematically clarify all roles involved in the processes, which can be categorized into operational and managerial tiers to reflect hierarchical responsibilities and data access needs. This table expands on the list of roles based on the primary entities involved. For simplicity, this case focuses on two functional departments and the role of general manager. This provides the starting point for RPIC, role. Subsequent efforts will revolve around the perspectives of these roles. Here, we'll begin by using two operational roles, chef assistant and sales, as examples to illustrate how to map out the information and process touchpoints for different roles. Sales and chef assistant are operational roles. Their data and process touchpoints are often concrete, involving the collection and entry of raw data, as well as initiating specific business activities. The sales key business activity is accepting sales orders and issuing work orders to the production center. Further analysis reveals that handling customer orders inevitably requires establishing and maintaining two related data objects, customer profile and product list. Without these, orders cannot be effectively created. For example, customer information should not be repeatedly entered across multiple orders, nor should product details be redundantly included in each order. This deeper analysis is represented by the extended arrows in the diagram. For the chef assistant, their business activities include receiving work orders from the sales department, placing purchase orders with suppliers. To handle this task effectively, two key data objects must be established and maintained: supplier profile and material list, receiving goods based on purchase orders, preparing food based on work orders, and issuing shipping orders to logistics providers. In the diagram, bold and red text highlights the identified business data objects, which correspond to the I information in the RPIC. In addition to these two operational roles, let's analyze a managerial role, the general manager. As shown, the general manager may want to analyze order trends as well as profitability. Both of these analyses rely on the foundational data managed by operational users, such as sales orders, work orders details, purchase orders, and ship orders, so no additional data objects need to be introduced. However, the managerial perspective may reveal gaps in the existing data architecture. For example, if the general manager wishes to assess processing center productivity, attendance data needs to be integrated. The costing context should be noted that in this example, Pudu uses batch costing, linking meal production costs directly to ingredient procurement batches, simplifying financial reconciliation. By analyzing the business activities of each role, we have mapped out the data and processes they interact with. Next, we will further refine the process and information components of the RPIC. Building on the data objects identified, we now define their attributes, the fields that describe each data object. Here, we provide a list of data objects and their attributes relevant to this case. For clarity, we use an entity relationship diagram to represent these relationships. Beyond the initial 8 data objects, 5 more emerge to enhance flexibility: product category, order details, price details, purchase details, and production details. For example, without order details, each order could only include one product, a clear inefficiency. The product category is introduced to allow customers to easily browse products by category, such as cold dishes, hot dishes, breakfasts, and set meals. While ER diagrams are a powerful tool, they are not the only way to design data structures. For simpler data relationships, using tables with annotations can also suffice. Regardless of the method used, the data objects derived from the analysis will directly correspond to the worksheets when building applications on a no-code platform. For views, they are typically created based on data ownership or data status. For example, My Orders is a view that displays data owned or assigned to a specific user. Pending Orders is a view that filters data based on its current state. When it comes to view permissions, it is recommended to define views based on roles, since the number of roles is typically small, and assign only the necessary permissions to each role. This ensures that users access only the data and functionalities relevant to their responsibilities, enhancing both security and usability. With roles and data touchpoints identified, we now dissect individual process to prepare for application design. Let's unpack the purchase based on work orders process, one of 5 core processes, as an example. This process is the business activity carried out by the chef assistant. This role receives work orders from the sales department and places raw material purchase orders with suppliers, checks auxiliary materials inventory, deciding whether to replenish auxiliary materials. Each purchase process concludes with supplier confirmation. On the right side of the flowchart, we can draft specific architectural content for each step. For example, the node for Create Material Purchase Orders corresponds to the creation of a custom action, a type of workflow, on work orders. The final content is the report for managers, which provides actionable insights to support decision-making. These reports typically include monthly and weekly trends in sales orders to track performance and identify patterns, monthly trends in customer acquisition and retention, customer composition analysis, breakdowns of customer demographics by dimensions such as size, region, or order amount, gross profit analysis, insights into profitability by product, service, or customer segment. These reports serve as blueprints for building custom pages and charts on the HAP platform. By systematically analyzing roles, processes, and data touchpoints, we generate actionable outputs for no-code application implementation. 1. Data structures as worksheet foundations. In this case, we have identified 13 data objects, including 4 detail subtables. Create these as worksheets with relationships established between them. 2. Create views based on order status. Multiple views can be created within the worksheets to reflect different stages of orders, such as draft orders, pending orders, and more. 3. Custom roles and permissions. All internal and external roles involved in the system will be created as custom roles within the application, with permissions configured accordingly. 4. Custom page and charts. The reports required by operational and managerial roles will serve as blueprints for creating custom pages with chart components added to visualize the necessary data. 5. Workflow configuration. The business activities of each role, along with their associated processes, will guide the configuration of workflows. Some workflows will be manually triggered by users via custom actions. Within this application built by HAP Implementation Specialist, different business processes are grouped via the top menu. Each group houses corresponding worksheets tailored to operational needs. For example, the product group includes worksheets for series, product categories, products, product details, and product recipes. The work order, a core data object identified during architectural planning, is implemented with a subtable for production details. This structure ensures traceability and scalability. Roles, the cornerstone of RPIC, are translated into the platform as custom roles with granular permissions according to their data access needs. In HAP, workflows are chains of triggers and action nodes that automate business processes. For example, the Create Work Orders workflow, it can be triggered via a custom button, and through data operation nodes, the relevant data from the sales order is mapped to a new work order. To empower decision-making, role-specific custom pages consolidate critical metrics into visual dashboards. For example, in this application, multiple dashboard pages are created, with different roles seeing different pages. With the foundational architecture in place, organizations can now leverage their blueprints to uncover untapped digital opportunities. Skipping architectural planning in favor of immediate application development risks myopic execution. Innovation thrives on visibility. A well-defined architecture acts as both a canvas and a compass, enabling leaders to ideate, validate, and scale transformative solutions. For customer-centric service extensions, the current case study omits customer experience design, a critical frontier for innovation. For Pudu, this might include developing an online self-service portal, allowing customers to place orders, save favorite menus, and track order status in real time. Automate SMS updates at key milestones, like your order is now in production or meals have been handed to logistics, or enable direct chef interactions for special requests, turning transactional exchanges into memorable experiences. For scaling for growth, scaling extends beyond headcount. More complex scaling strategies involve the introduction of multiple operational entities. Pudu Catering might expand to multiple production centers within a city to reduce delivery costs or scale nationally. A centralized digital system becomes exponentially more valuable here, amortizing costs across locations. By adding operational city and production center entities to its existing data architecture, Pudu can rapidly adapt its application for multi-site use, all predicated on forward-looking architectural design, what this course focuses on. So that's it for today. Thanks for watching.